since it has been a long time since Friday, when we talk about reference in polar notation, I'm looking for something here that indicates the length of the vector with its units, then this kind of upside down division symbol, and inside there goes the direction with appropriate reference. So this is the length of the vector, and this is the direction of the vector. There are 2 correct answers for this one. I'd like you to write down both correct answers, if you can. If you can't, I'll know. I'm going to roll the dice here and ask you in a minute. So take a minute, talk to your friends. Okay, so I'm going to correct you. 5 meters per second first, because that's the length of the vector. And then 30 degrees, and what'd you say?
North of west.
30 degrees north of west. How many agree? Okay, so this means turn towards the west first, so face west, then turn towards the north 30 degrees. Is that what's pictured here? I don't think so. What's pictured here looks like I started north and go this way 30 degrees. What you're telling me is to start west and go this way 30 degrees. Those are 2 different directions. So if we look at what this says, saying north of west means the 30 degrees starts on the west side and then turns towards the north. So we got it backwards there. This should be west of north. Okay, west of north. Because we start facing north and turn towards the west 30 degrees. So there's a second way of writing this, and the person in seat 27 is going to tell me what that one is.
I don't know.
Well, I don't let you off. Can you tell me what this angle is?
Which one? 60.
It is 60. So for every one of our representations, there's more than one way to write it. So this will be 5 meters per second, but our other angle that we could say is 60 degrees. But we need more, we need our reference. So this would start facing what direction? West, and turning what direction? So we are north of west. So this would be north of west. Now, I want to do more than this, but I'm afraid that we need to do another one of these first. Go ahead.
When we're writing like the west of north or north of west, do we have to write out the whole word? Or
No, just like I'm doing is just fine. And this is only for this unit. We'll never come back to this. Yep.
So if it's west of north, you start north and go 30 degrees west?
Yeah, because we are to the west from the north. But the compact way of saying is west of north. I usually try to tell students to kind of go backwards. Start with this direction, turning in this direction, and this is how much. Does that make sense? Okay. Let's do another one for practice just to make sure. And I'm going to do it right here in the same place. So move these over here. And let's say okay. There's our next one. There's 2 answers. I'm looking for 2 answers, please. We about ready? Okay, I need seat number 8.
One way you can say it is 10 meters per second, 20 degrees south of east.
20 degrees south of east. How many people agree with that assessment? I do too. Good job. Can seat number 18 tell me how to do the other way?
10 meters per second, 70 degrees east of south.
Sure. Excellent. Thank you. How are we feeling? All right. Now, here's where it's going to get a little bit trickier, okay? Let's focus on just one of these for a minute, this one. While looking at this one and knowing that this is how it can be written in polar, I need to figure out how we write this in rectangular, okay? Now, there's a variety of ways to do so, but I want you to consider that this is the wind. And this wind is blowing to the northwest, which means some of the wind is to the north and some of the wind is to the west. Our job is to figure out how much of the wind is to the north and how much of the wind is to the west. So in order to figure that out, we're going to need to use trig. And I want to give you some quality of life ideas on how to do that. So I don't know what your skill set is. I'm going to focus on what was given and tell you that you need to learn how to find the components of a vector. That's what this is called, finding the components of a vector. It's taking one vector and finding two right-angle vectors to describe it. Finding the components of a vector. It's taking one vector and finding two right-angle components to describe it. For this unit, all of our components are going to lie north, south, east, or west. So if you are barely struggling to figure this out, then I would tell you step 1, wrap a right triangle around your angle. So we're going to use this 30-degree angle. We're going to wrap a right triangle. So I literally mean draw a right triangle that encloses this angle. So I'm going to start by drawing one side like this. And then the right angle has to be right off of the first arrow. So right angle there. I am wrapping a right triangle around my angle. This is going to give me how much of the wind is to the north and how much of the wind is to the west. This is going to be us breaking our vector into its components. So after we wrap the triangle, we use trig to find the sides. That's on you guys. You're proficient, or you need to be. This should only take a moment. So find the length of these two sides. And then I'll talk about step 3.
The adjacent side is 9.94 meters.
I don't think it can be. I don't think it could be bigger than 5.
0.9.
So I'm going to run through it again. This will be the last time. If I'm using that angle, this is the opposite, this is the adjacent. So with that being said, That means 5 has to be the hypotenuse. I'm going to skip some of the steps because I've been practicing over the weekend. So I know that sine of my angle has got to be opposite over hypotenuse, and cosine of my angle has to be adjacent over hypotenuse, and tangent of my angle has to be opposite over adjacent. Noting what I have, it appears I have an angle and a side, so I'm going to use one version of my rules that I gave you guys, and I'm going to find out what the ratios are for the angle that I have. The ratio for sine 30 is 0.5, and the ratio for cosine 30 is 0.866. And I don't need tangent because I'll be able to get the opposite and adjacent, both of them, from what I have there. So now I just have to solve for the opposite side and solve for the adjacent side. So when I solve for the opposite side, I get 5 times 0.5, which is 2.5 meters per second. Any questions where I got any of that? We sure? Okay. So going to the next one. I'm going to have the adjacent side equals 5 times 0.866, which is 4.33 meters per second. This is the part that has to become invisible. So I've done the trig now. That means this adjacent side here is 4.33 meters per second, and this opposite side here is 2.5 meters per second. So I've effectively used trig to find the sides. Moving right along, I want to write my vector equation. Here's where you have lots of ways to do so. So I'm going to show you the different ways that are acceptable, and then the one I'm probably going to ask you to use, okay? We could say 4.33 meters per second to the north plus 2.5 meters per second to the west. This is an acceptable way to do it, but for what we're going to do in class, this probably would be the least valuable way of writing it. Because we're going to do some vector addition, so we're going to have to assign positive and negative to things. So another way to write it, and traditionally you write the x component first, would be to say it's negative 2.5 meters per second in the x direction. This little x with a little hat on top means in the direction of x. And it's a unit vector that just assigns it to be in the x direction. And then I say plus 4.33 meters per second in the direction of y. This is also an acceptable, I like this one better because it's got positives and negatives where they exist. Lastly, and this could show up on the exam, it's all over my AP, I just didn't assign anything like that. They love their IJK notation. How many of you have seen IJK notation? Well, you're seeing it today, so now you can't say you haven't seen it before. IJK notation just takes X and replaces it with I, Y and replaces it with J, and Z and replaces it with K. I don't know why you just wouldn't use X, Y, Z. I don't know, but I can say that IJK notation is very prevalent and shows up a lot. And they can use any of these methods in conveying to you a rectangular vector. What this is rectangular. And this is polar. What we just did was took a polar vector and converted it to its rectangular counterpoint. And these represent 3 different ways that you could write it. Everybody okay? Yep. Because if we look at our X and Y coordinate system, we generally accept these as our positivity and negative directions.
Thank you.
That's an excellent question. Thank you for asking. Okay so far? It's a lot to unpack. So tell you what, we're going to use this one for the rest of the day. Just the X and Y. Okay? That's what we're going to use for the rest of today. Probably for the rest of the year. I might mix in the IJK ones because I know it's on my AP, which means I could put it on a multiple choice test or something like that. So I think we should do that too. But for today, just X and Y. And since I want practice and I want you guys to be proficient, let's convert these, or this one, into rectangular. 3 steps. Wrap your triangle, find the length of your sides, and write out your vector. I know this is a lot for some of you. So wrap a triangle around your angle. I'm going to start along one of the cardinal directions. I'm going to draw it about as long as it would take so that when I make a right angle bend, I come right out to there. I am wrapping a triangle around the angle. Now I'm going to use all the trig to remind myself what those sides are to help me figure out the length of each side. I'm going to recognize I have the angle. So sine of 20 equals opposite over 10. Cosine of 20 equals adjacent over 10. I'm not going to worry about tangent because I don't have opposite or adjacent. But I can, using my calculator, figure out what the sine of 20 is and what the cosine of 20 is. Once I've done so, that tells me that the opposite side is 3.4 and the adjacent side is 9.4. So I now know the 2 sides. 9.4 meters per second to the east and 3.4 meters per second to the south. This is how much of the wind is blowing to the east and how much of the wind is blowing to the south. Go ahead.
What would be a good digit to round to when it comes to these?
I think when you get to to this point, I think 2 significant places is good because everything else is given in 2 significant places. Now that I have my 2, I need to pick a way to write it. 9.4 is in the x direction and is positive. 3.4 is in the y direction but is negative. Go ahead.
If it's positive, you want to write the plus sign, right?
I think it's better for you to do so, but it's not required. I won't enforce it on a test. So if you want to add vectors together, so again, I want to add the plane's own velocity, its airspeed, to the wind's velocity, and then get the ground speed, the first thing you have to do is convert all vectors to rectangular. The second thing you have to do is add like components together. So you add all the x parts together, and you add all the y parts together. And then 3, convert your answer to polar. 3 steps. So convert everything to rectangular, add like components, and then convert everything to polar. Okay. So it's the stuff we've already done. We're just adding this middle step here. So, because I think practice is important, let's say that the plane faces itself 35 degrees north of east, and is flying at 120 meters per second. let's say the wind, to make this go quicker, is 30 meters per second due north. So I want to find the ground speed of the plane. I want to add these two vectors together. Okay, we're going to do this together. Are you ready? Now, to do this together, I'm going to make a template. I would encourage you to consider a way that you would organize yourself, but I'm going to make a template. Here's what I think my template should look like. I'm going to write plane and wind. Those are the two vectors I have to deal with. On the top, I'm going to put X and Y, because I'm going to try and get my vector into both the X and Y direction. I'm going to add them together. That will produce my result. So my plane is 120 meters per second, 35 degrees north of east. I need to convert that to rectangular. My wind is 30 meters per second, due north. I got to convert that to rectangular. Now look, the wind was easy. There's no trig involved. 0 in the x hat direction plus 30 in the y hat direction. Right, didn't give you any trig there. If it's along a cardinal direction, it should be pretty easy to do because it's all in one direction. But I'll let you guys do the plane. You need the practice. So it was 120 sine 35 to get the y direction and 120 cosine 35 to get the x direction. I now have how fast the plane was flying in the x direction and how fast the plane was flying in the y direction. So we have converted everything to rectangular. Step 2, add. And you've lined things up in these columns, so you just add straight down the column. So 98.3 plus 0, 98.3 x hat. 68.8 plus 30, 98.8 y hat. Technically, this is the answer, but it doesn't tell you very much, so you need to convert it to polar.